distance increases, okay, your hydration temperature will be much more because of the hydration temperature will be much higher. Understand? Because it is very thin. It's very thin. It's easy to the heat easy to disperse. It's very thick. The heat in the internal is not easy to disperse. Understand? And then of course, the higher the cement content, basically this one will higher because more cement, more heat. Okay. All right.
So if the thickness is 250, we just take the 300.
Then you have to, because we do not have the formula for how they calculate this one. Okay. So you just take the probably more conservative. Okay. So let's say it's yeah, you can. That's the only okay. Okay, so it's 9:30. Let's look at so okay, so we conclude this. Okay, let me summarize this again. Okay, in a wall, whether it is water tank wall or earth retaining wall or shear wall, you will always have to design for the vertical and the horizontal. Okay, for the water tank wall, the vertical, this one at the adjacent to the water, this is the structural steel because they are taking the moment. This vertical and horizontal is to control the crack width. Okay, so basically you use that formula that to control a crack width due to temperature and shrinkage. Okay, remember we have two formulas to calculate the crack width. One is the formula which is for the crack width due to structural action. The other one is due to temperature and shrinkage. The one that due to temperature and shrinkage is this one. The crack width is S max multiplied by 1/2 of this temperature. Okay, and X max is calculated based on this. Okay, all right. Yeah. The other one that used to the moment, I think yesterday we have gone through with the calculations, right? Okay. Remember to calculate crack width due to the moment, the rebar stress are basically. Alright. Alright, since I have another class at 10, so let's quickly look at the assignment and get you going. The assignment is water tank structural design. Okay. This height here, okay, is 2500. That means 2.5 meters. So actually quite short. Okay, 2.5 meters. And this is the water tank. Cement XP up to here. Okay. So the figure above shows a cantilever which is part of a water tank. So this is part of the water tank because the water tank also has a slack, right? Okay. The tank retains water to a maximum depth of 2.5 meter. The wall thickness is 350. 350. Okay. Based on a ratio of height to thickness, ratio is equal to 7.0. That means how do I come with the 350? I base on the height to thickness ratio of 7.0. That means I use the 2550 divided by 7. So I get this. Okay. Because in the book they did tell you how to estimate the wall thickness, right? They just give you the wall thickness is 200, right? Okay. But the engineer actually has to come and estimate. So one of the ways for us to estimate is to use height to depth ratio. Design the vertical and transversal to limit crack width to 0.2 Limited per DS 8007 1987. Code of Practice for Design of Concrete Structures for Retaining Aqueous Liquids. Okay. Concrete grade is 35 MPa. Rebar strength is 460 MPa. Assume continuous construction of wall vertically and horizontally. Okay. Normally vertically will be continuous. In other words, they have the construction joint here, vertical construction joint, and then they cast from bottom to top. Okay. Alright. It's not like that means we don't have horizontal joints. The only horizontal joint is here. Okay. So if we have horizontal joints, it will be like you cast here, and then another one. Normally we don't do that. Okay. We either do one. Design vertical flexural rebar at the liquid adjacent based on deemed to satisfy allowable stress approach. Calculate pressure and verify. Okay. That means design vertical rebar at the liquid adjacent phase. Okay. That means you start out. How do you estimate the rebar? You use the factor load first. Okay. To estimate it, maybe increase it by at least. Normally, I would increase it by at least 50%. Okay. Or you can increase it by at least. I think the book increase it by 25%, right? 25%. So if you want to be you can do between 25% and 50%, means 35% like that. Okay, and then check deemed to satisfy approach, allowable stress approach. Then check the allowable stress. See where it's okay. Okay, and then calculation crack width to verify. That's all. In the test, actually I give in the test you don't need to start from scratch. I give you the reinforcement already. Okay, then you just need to check the rebar stress and the crack width. Yes. Yeah, OPC here 3. Okay, if you look at the British code, so the question is this: how do we know the OPC content? So if you look at this table here, here is the OPC. OPC is ordinary Portland cement content. So kilogram per meter cube. So this is 325, 350, 400. So how do you know which one? Depends on the concrete grade, right? So what's the cement content for different concrete grades? Where do you find it? Where are those information? No, don't know. Okay. If you look at this code, table 3.3, okay, lowest grade of concrete C30, minimum cement content 275 kg per meter cube, C35 300, C40 325. Okay. This is in the code.
In the code,
BS 8110.
So this one is a cylindrical one, right? So it
Huh?
是110
310. Table 3.3. Means you guys are still not very familiar with it. That means if you want to use C30 concrete, the code says that you have to have a minimum cement content of 275. Okay. Yeah, understand? So that means the higher the concrete grade, the cement content in terms of kg per meter cube, okay, in terms of kg per meter, is increasing. Yeah, all right. And then they have talked about the maximum free water rate cement ratio. Okay, so if you get C40, the maximum is 0.55. That means it cannot be more than that. Okay, cannot be more than that. Means it will have to be less than that. Less than equal to that. Okay.
Tadi ada 5. Ini kan tadi 325 ya. Kalau 2 itu
Okay. Also in the code, just now I just looked at that. Okay. Yeah. Cracking. Reinforced concrete. So cracking should be kept within reasonable bounds by attention to detail. It will normally be controlled by adherence to the detailing rules given in 3.12.11. Okay, where further attention required, the limit of the design crack width to particular values reference should be made to BS 8110 Part 2 324. So what this clause tells you is that reinforced concrete actually has cracks. Okay, but it's just that it's not visible to your eyes because we control the cracking in such a way that okay, it's not visible to the eyes. But nonetheless, if you put water through it, it will seep through. Okay, all right. So that is why reinforced concrete, the bathroom, we have to be waterproof. They put the tilings and so forth. Of course, the swimming pool, right? Okay, because why? Because the water, there are cracks there. It's just not visible to your eyes, but the water can seep through. Okay. Alright. So part 2. Okay, I think we'll stop here. Okay, and as I said, next week I will not be around. So you better ask by tomorrow. Right? Tomorrow I have class until 5. But the thing is, Monday, as I said, you will not be around because Monday actually we have actually 3 days of training, 4 days of training for the building information modeling. Yeah, a lot of lecturers will go. I don't know whether they inform you or not. Right? So, but the training is for 3 days, and the 4th day is an exam. So we have to so we cannot skip. That means to pass or fail. That means if you pass, they give you the certificate. Or normally because we have this KPI when we want to renew our professional license, we want to have a certain, so that is why we have to treat it seriously. Actually, I was thinking of initially skipping some of the time, but cannot. So make sure that but my strategy is, that's why I arranged a test tool for my other classes to be taken next week during the lecture hours. So that's why your class CV3308, CV3301, they will have that test tool. So I have to find. So for your class, I have talked to the lab technician, Rashika, to conduct it. And then for CV3301, I have talked to Dr. Nisa to conduct it. She's not going. Yeah. So, but quite a lot of us are going. Quite a lot of Naya Isam are going. She informed you, right? Raja now also going. But I think 7 or 8 lecturers are going. Yeah.
Sir, from Monday.
Huh?
The training is from Monday.
Huh?
The training is from Monday.
The what?
To Wednesday. And then on
Yeah, it's no. Next, the training is from Monday to Thursday. 4 days. 4 days. So the 3 Monday, Tuesday, Wednesday are training, and then Thursday is the exam. That means they want to make sure that you are listening, because some people go to training, they makan like this. So you need to be serious then. Okay, because we want to introduce the department trying to introduce the building information modeling into our curriculum. So that's the reason we go for the training. Okay, all right. So actually, we only find out about the exam only 2 days ago. We registered for the training 2 months ago, but we didn't know that because the registration was done by Raja. She registered for us and so forth. So only 2 days ago she informed us that, because I think some of us tend to skip, because I have one workshop for the bridging class students on Monday morning, 8 to 10. So I was thinking of skipping the early part, maybe the early sessions, because by the time because the training is in Kuala Lumpur, so for me to come here and go there, I think I will miss, I think the whole morning. So I think 2 days ago, Rajana informed us that we should not skip the training because there will be a test. There will be not a test, she said an exam. And He said that exam actually not easy to pass on. So we have to pay close attention. All right, thanks.